Hi, this is Chris Monck, owner of Highline Guitars. Have you ever thought about making your own pickups for your electric guitars? I've been doing it ever since I first got started. And the reason is I feel like if a guy who builds acoustic guitars has total control over the tone of the instrument, then why not the electric guitar builder? And to do that, you really have to wind your own pickups. Of course, you can buy some really great pickups off the shelf. There's nothing wrong with that. However, when you wind your own pickups, you get to experiment with wire gauges, the different kinds of magnets, the strength of the magnets, and the geometry of the pickups that you're making. So, what I wanted to do in this episode was to kind of share with you, not necessarily how I make pickups, because you can find that all over the internet. I wanted to share with you the most important tool required in making pickups, and that is a coil winder. So this is my pickup winder, and it's actually the fourth pickup winder that I've had over the years. And I'm not going to go into detail about what those other pickup winders were like, but I will say that everything I learned building and using those winders went into making this fourth and final version. It is based on a sewing machine motor, which I picked up on eBay. They usually cost anywhere from 25 to 30 bucks, so they're not that expensive. And the nice thing about these motors is they're designed to operate on a variable current. So you can adjust the speed, and the motor is designed to work with that. A lot of motors have a fixed speed that they work at, and if you try to vary the speed with a potentiometer, the motor eventually will burn out. But these are designed to work that way, so that's a nice benefit of using one of these type of motors. And what I've done is I've plugged it into a router speed control, which I picked up at Harbor Freight years ago for like 20 bucks. And I think they still sell them. The motor itself at maximum speed spends about 7,000 RPM, which is way, way, way too fast to wind a pickup bobbin. It has to be down around 1,000 RPM. So what I did is I have a 1.5-inch V-belt pulley, and that is driving a 3/8 inch wide 3L200 belt. The 200 refers to the size of the belt in its, I guess its length. And that depends obviously on how far away the motor is from the drive shaft. So that belt then drives this 4-inch diameter V-belt pulley, which is installed onto a 1/2-inch diameter precision ground drive shaft that's running through a pair of pillow blocks and keeps it all pretty stable. At this end, I have a 1/2-inch diameter or 1/2 inch thick, I believe it's about a 5-inch diameter plywood plate, which is installed onto the shaft using a 1/2-inch inside diameter collar that is held into place with a set screw that's tightened against the shaft. And that collar is epoxied into the back of this plywood plate. And what's critical about these plates is when they're spinning, they have to be absolutely parallel to the drive shaft. You can't have any run out. It needs to spin perfectly straight. So while I was gluing it into position, I was using a dial indicator pressed against the outside as I turned the plate, or as I turned the shaft, and I carefully watched the run out and continued to make slight adjustments while the glue was setting until it stopped moving the dial indicator. It stayed at 0. And so now it runs pretty straight. And to count the number of turns, which is obviously critical when winding pickups, I'm using it's a simple digital counter that I picked up on eBay. And this particular one is, it operates with a proximity sensor, and this is that sensor. And what it does is it reads this magnet, which is epoxied to the edge of this plate. And every time it comes around and passes in front of the sensor, I get a advance of 1 digit on the counter. And this particular counter is a 5-digit counter. You need at least 5 digits if you're winding pickups. 4 digits are out there, but the problem is some of the pickups bobbins that we wind have more than 4 digits in total number of winds. It could be 10,000 or 11,000, and when you get into that, you need to have a 5-digit counter. And it has a reset button here, so I can reset it to 0 just by pressing it. So then I have, this is the traversing mechanism, and I don't know if you can see it. Hopefully that'll focus. But it is consists of a 1/4-inch diameter shaft that's running through these 2 blocks of wood. And on either end I have these set collars which governed the amount of side-to-side movement as I'm winding the copper wire onto the bobbin. And each bobbin has a different dimension as far as its height, so I can adjust the collars as well as this is a little nylon spacer that's held in with a set screw at the bottom. It has a groove in it that the copper wire goes through, and I can adjust the spacing so that I can move this to the proper side-to-side distance in order to fill a bobbin. And then that copper wire runs down through, this is a tensioning device, and it's nothing more than a knob with a screw that runs through this block of wood, and I've got a T-nut underneath here that it runs through. And the end of this block of wood is rounded off, and the copper wire comes up from the floor off of a spool, runs through or runs in between a pair of felt washers. And I actually pulled these off of a cymbal stand on a drum set that I had, and it just presses down as I tighten this knob, and that gives me the kind of tension that I need in order to wind the bobbin so that it's reasonably tight. So that's kind of how that works. To operate it, once I've got my wire installed onto the bobbin, I can just fire it up. And that's really all there is to it. It's so simple. So that's basically how my pickup winder works. And at this stage, I can't think of anything else I would do to improve its design. So there you have it.